The key to building quality into our software is making sure we can get fast feedback on the impact of changes. In continuous delivery, the goal is to run many types of tests, both manual and automated, continuously throughout the delivery process. In this section, we'll see how to integrate continuous testing into a pipeline to find problems as soon as possible and make the lead time from check-in to release as short as possible. Testing is a critical part of continuous integration and continuous delivery. Unit tests validate individual methods and classes and are a great start to prevent issues, but you'll also need to run integration tests to make sure that different modules used by your application interact properly together. In this section, we'll see how to add integration testing to our sample application in Visual Studio 2017. We'll see how we can run these tests from our continuous integration builds and publish the results from the test execution as part of the CI process for the entire team to have insights into test execution. Finally, we'll have a look into .NET Watch tools and how we can trigger automatic compilation and test execution in real time whenever a code change is made during development. The previous section of our course, we saw how unit tests help us better design and allow to work without being afraid of modifying the code. Unit tests are normally used to check if the output of unit of code conforms to the desired results. In this video, we'll have a look into integration testing in ASP.NET Core, which help us to check if different parts of the application work as expected when they are assembled together. Integration tests verify that different parts of the application work correctly together. Unlike unit testing, integration tests frequently involve application infrastructure concerns such as database, file system, network resources, or even web requests and responses. Unit tests use fakes or mock objects in place of these concerns, but the purpose of integration tests is to confirm that the system works as expected with these systems. Integration tests, because they exercise larger segments of code and because they rely on infrastructure elements, run slower than unit tests. Thus, it's a good idea to limit how many integration tests you write, especially if you can test the same behavior with unit tests. Testing the logic within our own methods is usually the domain of unit tests. Testing how your application works within its framework, for example with ASP.NET Core or with a database, is where integration tests come into play. Creating integration tests from our API involves the following process. We need to create a new .NET Core test project, add NuGet packages for the test host, which will be used to service test requests without the need for a real web host. This way, we can run the integration test for our API from a CI build without needing to deploy the application to any environment. Finally, we need to create and configure a test server that can be used to simulate ASP.NET Core application for testing purposes. Let's open our sample application and have a look into how we can add integration tests for ASP.NET Core applications. I'm into Visual Studio and this is our sample application, the web API for Windows. And I have added an integration test project into this one. If you want to add a new test project to your solution, you have to go add new project and choose unit test project for .NET Core. If you choose this one, dependencies and the NuGet packages for running tests like the test SDK and all those things will be automatically added to your test project. So I've already added that. So if you can open the project and if you go to the NuGet packages added to the project, you can see that I have the .NET Test SDK. This is added as part of the project type that I choose. And then I have added a NuGet package for ASP.NET Core test host. As I said, this will help us to simulate the actual web host behavior. So I don't need to host this application to run tests against the website. Finally, I have some mocking packages added because I don't want to use the actual implementation of my database and things like that. So I have mocked some of the layers. I will show you when we reach there, and some of the packages that help me in unit testing like Shudi and Automapper and all those things. The interesting thing to look is the test server. As I said, this is the test server implementation, and in the test server, instead of using the actual startup class from the ASP.NET Core Web API project, I'm using a test startup class. So in the test startup class, if I go into the test startup class, you can see that I am setting up a database context over here and overriding the default database context. And also I'm setting an in-log memory provider, so in-memory log provider, so that I don't have to log it to the console, but I'm logging to in-memory. So if you look into the setup of DB context over here, What I'm doing is, if the environment is integration test, I'm using an in-memory database. Otherwise, I'm using SQL Server. So I don't want to connect to SQL Server when I run my integration test, but I'm just hosting an in-memory database, which the .NET Core Entity Provider does that for me. And I'm starting this test server over here, and then I'm creating a client that runs on HTTP localhost. I'm not hosting this application, IIS or Kestrel or anything like that. I'm just using the test server to host my application. Now, how this is used is I have my tests over here. For example, I have a test to check the controllers. And in this test, I am initializing the test server during the class initialize method. And I'm using the controller, if you go here, to send a request to the client. So the client is running on HTTP localhost, and I'm sending requests for our API. So if I'm creating a new Wonder, then I'm just posting the JSON as I post to a normal controller, a normal API that is hosted on IIS. And you can see that over here, you can see that in the test, I'm actually creating a new Wonder by sending a post request of this particular object, and then I'm checking whether I get an OK result back. I can run these tests by going over here. So I'm just going to run all the tests. So the project is going to build, and then after successfully building the projects, it's going to run these tests. And you can see that a couple of tests has already been finished, and some of them are already running. All right, my tests finished. So if I go here and check, these are the unit tests and these are the integration tests. You can see that there is a difference in the time that took for the test to execute. So unit test runs much faster and integration test takes some time. So this is why we try to reduce the number of integration tests as much as possible and try to cover up the testing functionality in the unit test if possible. So some of the tests which we need to do, verify whether the application works with all the components integrated together, we have to do it through integration test. But the logic testing in individual methods and all those things, we should do unit testing by mocking the parts which we don't need as part of the testing context.